Let's discuss question number 8 from test 3. This is from thermodynamics. Which of the following factor causes the process to be irreversible? Well, the options are friction, unrestrained expansion, heat transfer across a finite temperature difference, all the above. Well, you know the answer, but let's understand. Friction, well, if I apply a force F and take a body from position 1 to 2, okay, you have the resistive force called friction. You need to do some work against friction. Now you have to bring back the body from position 2 to again position 1. So you are just taking body from 1 to 2 in one way, but you're doing some work against friction. Now you're taking the body from 2 to 1, okay, in this way, but then again you do the friction opposes and you do the work. So the body has come back to its original place by a combination of these two processes followed one after the other. The body has come back to its original position, but some heat or some work has been done on the friction on in both of the process. So that heat will be converted into that friction, I mean that work done which is spent against friction in both of the processes will be converted into your heat and it will be absorbed. There will be a change in the surrounding. So I can't say that this process, the forward process, or if you take individually any process, the process will be reversible only when you carry out the reversed process. So a process is said to be reversible process only when you carry out the reverse process, both the system and the surroundings should be brought back to the same state. But that's not happening in these two cases. When you combine these two, effectively the body is brought back to the same, but the surroundings are not brought back because there's an finite amount of heat that goes that is produced because of the work done against friction in both of these processes. Okay, so friction leads to irreversible process. Now in the same way it can be shown by this is a simple example to show that friction causes irreversibility in the system, whereas in the same way you can show that unrestrained expansion, that is, you have something like this, you have a air on one side and the other side is vacuum, or some high pressure gas on one side, the other side is vacuum, and you open you just remove this diaphragm, so this suddenly expands. Now this sudden expansion or unrestrained expansion is also a case for irreversibility and finite. So both the first one and the second one causes irreversible heat transfer across a finite temperature difference. Well, it can be shown that when you are transferring heat from a high temperature body to a low temperature body, this heat transfer is basically irreversible. It cannot be reversed, okay, because if you want to reverse it, you need to have a refrigerator which basically supplies, but then it will require the work, okay, it will require the work that has to be done. And so the system can be brought back, the surroundings cannot be brought back if you reverse the process. So all these three ABC, that is friction, sudden expansion or unrestrained expansion, and the heat transfer across a finite temperature difference, all these are examples which causes the process to be irreversible. So the answer is D. Thank you.